Hey there. Today we're going to be wrapping up our lessons about sequences, and we're once again going to look at explicit sequences, and we're going to potentially look at the idea of arithmetic and geometric, but today we're going to look at the idea of neither, okay? So today we're going to write an explicit rule for a non-arithmetic or non-geometric sequence given the sequence itself. So in this case, you guys, sometimes we may encounter sequences that are neither arithmetic nor geometric. What we can still, that doesn't mean we can't write a rule for them. What we can still do is look for relationships between the position and the value of the term in order for us to write an explicit rule, okay? So in this section, when it asks you to write a rule for the nth term, this directive is telling you to write an explicit rule. Okay? That means that you're going to just use n. Okay? You are not going to use a sub n minus 1. That's a recursive rule. Okay? So if it wants a rule for the nth term, remember we talked about how recursive rules are fine and nice, but explicit rules are so nice because you can use an explicit rule and find like a sub 258, you know what I mean, without having to do a lot of like backtracking, okay? So that's what we're going to do. We'll write what the next term is, so we'll establish the pattern, write the next term, and then we'll write a rule for the nth term. Now, for sequences that are not arithmetic or geometric, my suggestion is going to be to write the position over each term. Think about like powers, stuff like that. We'll work through this. All right. So in letter A, in this question, we have 3, 5, 7, 9. Okay. As far as our next term goes, our next term would be a sub 5. Can you guys tell the pattern what that would be? Where it looks like we're adding 2 each time, so our a sub 5 would be 11. Okay, so that's my next term. Now it wants us to write a rule for the nth term. And hopefully you guys are seeing that this, because we're adding 2 each time, that this is arithmetic, right? Because we're adding 2, adding 2, adding 2. This is going to be arithmetic with a common difference of 2. And we know that arithmetic rules are linear in nature. And so we know that we're going to have a sub n equals, and it's going to look linear. Because my common difference is 2, that's going to look like the slope of our linear equation. And then as far as the next part, remember we do not put a sub 1 here. We have to go backwards and think about what our what our a sub 0 term would be. So if we work backwards, that means that that's going to be 1. And so we would have a sub n equals 2n plus 1. And that would be my rule for the nth term, right? So we know how to do that. That was arithmetic. Let's look at the next one. 3, 10, 29, 66. Ooh, goodness. What the heck is this pattern? Well, if I look, maybe I could add. I don't know, let's see. If I take 10 minus 3, that means I'm adding 7. 29 minus 10, I'm adding 19. 66 minus 29, I'm adding 30. I don't know what is happening here, okay? So sometimes we're not able to find the pattern kind of intuitively like that. And obviously multiplying doesn't work. Like if we wanted to try to find a common ratio, we can tell that like these really aren't any patterns either. Yikes, okay? So what I'm gonna suggest that we do is to write what the position is up here, okay? And so this is when n equals 1, n equals 2, n equals 3, n equals 4, etc. Okay, and we know here, down here, this is where my a sub n is, that these are where my a sub n values is. So first, let's look. Can we do something to 1 to get to 3? that we could do to 2 to get to 10, that we could do to 3 to get to 29. And again, I'm not seeing anything pop out right away, right? I'm adding 2, adding 8, adding 26. That's not helpful. Multiplying by 3, multiplying by 5, not multiplying by 6. So it's hard to see. So if we can't do that, we're just going to have to try to be creative. So what I'm going to try to do is maybe do some different things to the position. So one of the things I can do is maybe try squaring it, all right? So let's see what happens if I have n squared, okay? N squared, 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16. And you don't have to rewrite these numbers again, but again, what we would try to do is see if there's a way that I can go from 1 to 3, from 4 to 10, from 9 to 29, from 16 to 66. And once again, like I'm a little disheartened, okay? Okay, so n squared didn't work. Let's maybe try n cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. And then again, I'm going to compare them to those original numbers, 3, like the values of the sequence, 3, 10, 29, 66. So is there anything I can do to get from 1 to 3, from 8 to 10, 27 to 29? Oh my goodness. All I need to do is take these, and these are 2 more than that. So what that means is that for my rule, what I did is I took n on its own didn't work, n squared didn't work, but cubing n worked. So I'm going to take n cubed, and then I have to add 2 to it. And that's going to be my rule. If you're not sure, substitute it in. 1 cubed plus 2 is 3. 2 cubed is 8 plus 2 is 10. 3 cubed is 27 plus 2 is 29. So you can always double check your rules. Now, the only other thing that we haven't done yet is the next term, because we had trouble. But now that we have a rule, it should be really easy for us to find our next term. What we can do is we can find our a sub 5. And now that we have a rule, we're just going to take 5 cubed, which is 125, plus 2, which is 127. So that will be my next term. Okay. All right, let's try letter C. We have 2 fifths, then 2 25ths, 2 125ths, 2 625ths. And I'm seeing I'm not adding anything, but I do see, I hope that you guys see that as I go from here to here, I'm multiplying by 1/5. That's a pattern that we've looked at before. And what that means is that this is going to be a geometric sequence with r equals 1/5. And so the rule that we can use, as we know for the geometric, is we do use a sub 1 for geometric, so I'm going to take 2 fifths. And then I have times 1/5 r raised to the n minus 1. And that would be my rule. Okay. Again, because we know that geometric is exponential with that kind of a rule. All right. The other thing we didn't do is do what a sub 5 is. And in this case, I might not want to use the rule. This time I just might say, all right, I'm just going to multiply this by 1/5. So if I multiply 2 6/25ths by 1/5, basically I'm just multiplying the 625 in the bottom by 5. Multiply the 2 by 1, multiply the 625 by 5, and that gives me 3,125. That would be that next term. Okay. Let's try another one. Letter D. 2, 8, 18, 32. Here it looks like I'm adding 6, adding 10. Okay, so not arithmetic. multiplying by 4, not multiplying by 4. This is not arithmetic or geometric. So because this is a neither, I'm going to maybe write my n values up here to see if I can figure out what to do with them. Okay. So is there anything I could do to get from 1 to 2, from 2 to 8, from 3 to 18, 4 to 32? And I do see a pattern there, like I'm multiplying by 2, by 4, by 6, by 8. But as far as the value of n itself, it's just a little too much for me still. So I don't really see anything that's here. So again, just like we did over here, let's maybe try squares. Let's try n squared. N squared is 1, or 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And again, you don't have to write them underneath. I'm just being dramatic here, but these are the values of the sequence that we're dealing with. Is there something we can do to get from 1 to 2 that's the same as 4 to 8, 9 to 18, 16 to 32? Hopefully you guys see that yes. All I need to do is take these values, which are n squared, and multiply them by 2. So our a sub n means that we're going to take n squared and multiply it by 2. Instead of saying n squared times 2, it is best just to write it as 2n squared with the coefficient in front. Okay? And again, maybe we could have figured out a pattern before, but if not, we can go back now that we have the rule and find what our next term is. A sub 5 means we're going to square 5 and then multiply by 2. So 5 squared is 25 times 2 is 50. Okay. So letter E. In letter E, when we have something like this, we're looking at 8/5 to 9/10 to 10/15 to 11/20. And I understand that you might see a pattern, but if we go from fraction to fraction, like 8/5 to 9/10 is not a relationship that's the same as 9/10 to 10/15, right? But maybe you guys notice that if I just look at the numerators, there's a pattern. Or if I just look at the denominators, there's a pattern. So oftentimes what happens if we have a fraction, what we can do is try to write like a separate rule for the numerator and the denominator. So try to write a separate rule for the numerator and the denominator. Okay. So let's just look at our numerator. Okay. Our numerator is 8, 9, 10, 11. That's a pattern, right? What's happening is that we can hopefully see that we're going up by 1 each time. And so since we're going up by 1 each time, that means that it is arithmetic, right? So our numerator, we can see that our common difference is 1. And then if we wanted to write a rule, we would just have to work backwards, and our a sub 0 term would be 7. So in my numerator, I'll just kind of like put a little put a little circle around it. The rule would be that, okay, I'll put a sub numerator. A sub numerator then would be 1 times n plus 7. Okay. Again, that's not my final answer, but that's what I decide for the numerator. And I know I don't need the 1. I'm just being dramatic with the common difference. Okay. Now let's look at the denominator. If I look at the denominator, I have 5, 10, 15, 20. Hopefully, once again, we see that this is arithmetic. We have a common difference of 5. And if I were to go backwards, then I have an a sub 0 of 0. So my a sub denominator, And again, you don't have to do all of this work. I'm just trying to, like, you don't have to label it like this. I'm just trying to make sure that we're clear. The a sub denominator ends up being 5n plus 0, or just 5n. Okay, so this is like kind of like what you're doing in your head. And so now that we have a rule for the numerator and the denominator, that means that I'm going to have this rule for the whole thing. My rule for the numerator is n plus 7. My rule for the denominator is 5n. Okay. A very popular answer for this, you guys, is that the numerator is n plus 1 and the denominator is n plus 5. Do you see why people would do that? A lot of times people do that because that's what you're adding to the next term. But I urge you guys, anytime that you write an explicit rule, substitute it in. If I have a sub 1, 1 plus 1 is not 8. 1 plus 5 is not 5. I can tell that this is going to be incorrect, okay? So make sure when you feel that you have a rule, substitute a couple numbers in and make sure that you're good. We probably should have done this before, I apologize, but we can find what our a sub 5 is. It's obvious that our next numerator is going to be 12, and our next denominator, if we add 5, is going to be 25. Okay. Great. So now that we've done a couple of these together, I know it's a video, but I'd really like you guys to try to do these next 4 on your own. If you wait and just copy it down, the problem is that you're not using your brain, you're just being very passively learning. I'm really gonna ask that you press pause and then kind of, go through each one afterwards to see if you guys have any questions, to make sure that you can do it on your own, okay? All right, so I'd like you guys to try the next you try questions. There are 4 of them that are here. And then when you're all done, you can unpause and then see how you did. Okay, hopefully you tried these on your own. Letter A was a neither. So I tried the writing the position tactic. The positions themselves didn't help. N squared didn't really help. But I noticed that when I did n cubed, it was just the opposite, which means I multiply by -1. So my rule is a sub n equals the opposite of n cubed, and a sub 5 would be -125. Letter B, hopefully you didn't do too much work here. This time we're adding 3 each time, which means it's arithmetic. So we can use this rule. So because the common difference was 3, and if I work backwards, my a sub 0th term is -1. That would be my rule. And then if I have my a sub 5, again, I could add 3 to this or even substitute 5 in here and I get 14. In letter C, this is again on its own is a neither. And so I just made a little note here that in the numerator, I'm just, that I have n times 2 each time. You also could have noticed that in the numerator, if I just look here at 2, 4, 6, 8, that this is arithmetic with a common difference of 2. And so since my common difference is 2, that's going to be the slope of the arithmetic part. Working backwards, I have a 0th term of 0. So my numerator is 2n. And then in the denominator, I'm adding 1 each time, which means that my quote slope unquote is 1. And my a sub 0th term then would be 2. So again, a couple ways that you can do some of these easier ones. You could write what the values are and say, oh, look, I'm doing this to n each time to get the rule. Or if you notice that the numerator and denominator were arithmetic, we could write the arithmetic rules like we did above in example E. Okay. In the last one, in this one here, this one again is a neither. When I wrote the values for n, I didn't really see a relationship. But when I wrote the values for n squared, I saw that, ooh, look, these are all just 4 away from the values. So my rule is a sub n equals n squared plus 4, and therefore a sub 5 is 29. Okay? Now that being said, again, when we do have arithmetic or geometric sequences, it is, as we are seeing, best for us to fall back on those since it's not quite as complicated. We have like specific rules. But I want to make sure that we know that if it's not arithmetic or geometric, that doesn't mean that we can't write a rule for a sequence. We just have to try to be creative and to brainstorm a little bit. Okay? I hope that helps. You guys have an awesome day.